Well, so let's go for a round of introductions here. Gwen?
Hi everyone, Gwen Shapira here, Principal Data Architect at Confluent. Confluent is a company that has Apache Kafka distribution. I help our customers build pretty cool event-driven, data-driven architectures on top of that.
Hi, my name is Greg Osuri. I'm the founder and CEO of Overclock Labs, the company behind Akash Network. Akash is a decentralized cloud infrastructure platform, fully open source, as well as open data. And what we do is we connect Slack server capacity with users that need it in a decentralized manner. And serverless is our primary abstraction to access these services, as you know, because in a decentralized ecosystem, you don't necessarily have access to the underlying server. And we've been a big proponent of serverless. We've been working on it since 2015. Our first product was an operating system called Disco. Disco stands for Distributed Infrastructure for Serverless Computing Operations. Now we focus primarily on stateful applications, stateful serverless applications.
All right. Hey, I'm Komal, and I run everything related to money at Uber. So this includes payments, fraud, insurance, revenue and economics, and so forth.
That's pretty good. That's pretty good. Well, thanks for being here. Serverless, it's one of those trends that we've been mentioning and talking about in this conference, Kong Summit. And we're seeing that there is a rise in popularity. Cloud providers offering serverless offerings. We do also have lots of serverless frameworks that are coming out. Why do you think the time is now for serverless? Why do you think serverless has increased in popularity?
It's kind of like cloud taken to the extreme, right? I mean, everyone goes to cloud because it allows you to pay only for what you use and less operational burden, easy scalability. Those same factors are what makes everyone also want to do serverless.
Yeah, I think to that point, productivity. I mean, how long or how fast can you get up and running? In some cases, it's much more than productivity. In our case, it's actually a requirement, right? When you have to perform operations on a giant state machine, there's really no way you can, you can have abstractions that's lower than a functional or a runtime, right? So serverless for me is just an amazing, evolution of the cloud and the true promise of the cloud.
All right, so look, the world is getting complex. The problems are getting complex. The easy problems are solved already. And so every company is looking for that unique value proposition that that company could provide. And on the other hand, we don't have enough talent in the market. So when you have that precious resources, where do you want to spend them? You want to spend them on what your company can provide, the unique value, versus something that's already commoditized. And as somebody said here, that serverless is an amazing place to be, where you don't spend your cycles in things that are already solved.
And also, I think with the explosion of data, we're seeing more new engineers coming on board, especially data engineers, right, that may or may not have experience dealing with shell scripts. I think we're seeing a good growth of new engineering talent coming in, and serverless is an incredible interface for these new engineers as well.
I would disagree. I think serverless and data is still to a large extent an unsolved challenge, as in serverless are mostly stateless, and as stateless app, you're kind of limited in what you can do. You have to get your data from a database. It has large overheads to doing so. I think we're still evolving the patterns that really allow you to use big data, especially, and serverless in a cohesive manner.
Yes, there is, one.
Excuse me for 1 minute. I would like to let Guillermo introduce himself.
Hello. So I'm the CEO of Zeit, and we build a serverless platform for Docker containers. So we take a slightly different approach from the rest of the market in that we allow you to bring your applications and your source code and your runtimes and your frameworks that have already been written, and we execute them serverlessly. So that means instant cold boot ups socket-driven activation, request-driven activation, self-healing, auto-scaling, and a lot of other fun things that we'll discuss now.
Yes, to that point, there is a degree of applications that are stateless, but there's a good degree that are stateful, such as blockchain-based applications, right? A smart contract, in a sense, is a serverless abstraction where you do definitely deal with huge amounts of data, and it abstracts to a level that you don't have to necessarily deal or worry about the size of the data, but actually perform operations. Yeah, so I think there's an interesting mix of blockchain-based applications coming in.
Yeah, but that's super cutting edge. If you look at what people are doing right now, I'd say 90% of the use cases are either stateless or they probably, if they have state, they store the state in like S3, DynamoDB, like totally external state.
I think the issues of state has to be very carefully delineated because there's always a state, right? Otherwise, the applications don't do any work. So we have to decide, okay, where do I pick my battles with regards to retaining state? For example, the issue of cold instantiation or an application being warm, in a way, it's introducing the idea of like there is some state somewhere that's holding your pre-warmed VM, for example, so that you can evaluate JavaScript really quickly. So I think with regards to state, it's what serverless is showing us is we can let the developer worry about a lot less state. I think we always worry about state because, for example, how quickly are you retrieving from your cache? What's the penalty you're paying with the cold boot up? What's the penalty you're paying by reading from a database in a different region? So I think it's a very nuanced conversation that has to be had with regards to, okay, what are the battles that I'm picking with regards to holding state?
So one of the things I noticed, a lot of people are really worried about cold starts. Like it's literally the first thing everyone asks me when I recommend doing anything serverless. And when you actually measure reality, it's like the difference between 100 milliseconds warm start, if you use Python on AWS, and then maybe 200 milliseconds if you have a warm start. And there's very few use cases where 100 milliseconds is fine, but 200 milliseconds is way too much and totally unacceptable. It's like, it just feels like something that people needlessly obsess about. Obviously, if you're using Java, all bets are off. If you're on Azure, all bets are off. And there's like there are some differences, but in general, it just feels like the thing everyone knows to worry about, but not necessarily the thing that makes the biggest difference.
Yeah, I think it comes down to the architecture, right? Most long-running jobs, you require lower latencies, and most batch, you don't. And when it comes to a starting problem, like most contracts or smart contracts are usually invoked by a human or invoked by an event, where the start problem is not necessarily a thing yet, to your point.
And it's also built into your resource scheduling algorithm. So, I mean, I agree with you that obsession is sort of pointless. But it also, not to undermine the challenge, there is a need to acknowledge that cold start time, and then how do you bake it into your resource scheduling aspects? It does matter.
So in your experience, where did you see serverless being successful? What use cases make serverless a very successful technology?
I can go for, All right, so changing context a little bit, where I have seen, where we have used, so at Uber, we started our tech from the opposite side. We actually built our own servers and our own data centers and so forth. But we are slowly migrating into what we call a tripod strategy, where we want to utilize the external clouds. And the places where we are focusing on right now is specialized ones, where, for example, PCI-compliant hardware, it's very expensive, and it's not worth doing it within our own data centers. Or when you have multimodal devices and you need to manage and test various devices, then you can use that transient workload. You can push it off to serverless. Also deep learning. So we are putting a lot of effort in facial recognition, OCR, and computer vision, and so forth. And sometimes it's a trial and error. And before you go and buy those expensive hardware, how do you utilize what is available on Google Cloud or AWS is where we have started from.
Yeah, actually, that's a surprising one, and most people don't realize. But you need a lot of resources and a lot of state to train a model. But once you have a trained model, serving the model is kind of a classic serverless example. And it's just one of the things that sounds like it's way too advanced to do in like one little function that is totally transient. But it is actually a very good use case.
Yeah, for us, man, there's really no other way. If you're writing a smart contract or anything, serverless is the only way to execute or even perform. So I would say 100% of the use cases that I deal with are serverless.
I think every use case where the network can be the scheduler, meaning every time you have an incoming request, an incoming event, an incoming connection, and you can do computation as a result of that, meaning that you didn't have to do it previously, wasting resources and over-provisioning and so on, which in my experience is the vast majority of the things we do. So like you were saying, you train a model, but then you have to expose it over an HTTP transport. So that HTTP transport, I think, is best suited to plug into a serverless framework. So I think everything that we do in the cloud would have at least a very significant percentage of the workloads will move to the serverless model.
So Guillermo, there are two different factions in the serverless world. A faction that believes that everything will become serverless, right? Serverless will replace every other architectural pattern. And then there is another faction where serverless can be an extra tool for certain specific use cases that is going to work alongside more traditional architectures. What do you believe?
I think the latter is a more realistic way of seeing how this will play out. An example is the 200 to 400 millisecond difference can be very critical for many, many applications. So I think some of those very critical core APIs might remain in a more stateful cluster. But I think that the way that app developers will interact with those APIs will be by deploying serverless applications that act as satellite applications that query a core cluster perhaps. Because sometimes, in addition to the 200 and 400 millisecond difference, you have that compounding effect of having to connect to databases, establish a new connection pool, for example, establishing new TLS handshakes, and all that kind of becomes more unpredictable. Like the serverless world is a little bit more shaky, more irregular to the 99th percentile. So I think we're entering a hybrid world where I think more front-end facing developers, more what we call the middle end, someone that is not fully back-end but is not also uniquely just front-end, all those workloads we see moving to the edge and we see moving to a serverless model of execution.
I have a totally different take. I think that what the gaps that you're seeing is in serverless, it does not do everything. It's temporary. Like the cloud providers are going to solve it. They are going to, and you see in general how disruption works. You start with very limited use cases, a lot of limitations, and you ramp up to the bigger and more challenging things. And the core economics of focus on your use case and the business value, don't focus on operations, pay only for what your business needs, don't pay for infrastructure you're not going to use. This is so compelling that every organization will try to move everything they have as much as possible to this model. And I think that going forward, they will be able to force the cloud providers to ramp up their game. We see that a lot. The moment you have large financial institutions use your framework, you are forced to up your game. Like Confluent has been time and again forced to be more PCI compliant, do things we never thought is even possible with our infrastructure. Do GDPR in Kafka, which was, we didn't think it is possible, exactly once we didn't think it's possible. You are forced to do it the moment you have very large financial customers. And I'm seeing my large financial customers increasingly going serverless, coming up with use cases, and making the frameworks do what they need them to do.
Yeah, I think I had to agree with Gwen because especially what we're noticing, any new cloud provider, we're a brand new cloud provider, the first choice is serverless, right? And seeing a whole new generation of programmers that don't really care about deploying a server, and they're way more comfortable in a serverless environment. So if you look at the same argument about cloud, at one point, there's a degree that folks that didn't exactly agree that cloud is going to be the primary driver for hosting.
Yeah,
where
so
the
many people
reality
said
is
we'll never do cloud, and
we'll
here
never
we are.
exactly. I think in the same direction as the technology evolves, we're going to see more and more serverless adoption. Now, will there be a scenario where everything will be serverless, or it's going to be like trucks and cars, right? There will be people that are still going to drive trucks, but that number is going to be so minimal compared to the car drivers.
Yeah, I think the distinction to make is new organizations versus existing enterprises. I don't think existing enterprises will realistically just say, oh, from today on, we're serverless. So I'm trying to predict what will the uptake of serverless look like in those organizations. So most likely, they will create new applications that are interacting with existing non-serverless deployments until, like I said, in our vision, the vast majority of users of the cloud will be on serverless because of the reduced error rate, the on-demand scale, the on-demand pricing. So there's so many benefits. So I agree that it's hard to turn that down.
A year from now, we'll be seeing IBM serverless on the mainframe. That's the way everything goes.
So let's talk about this question comes actually very timely. We at Uber did a very deep analysis recently around all our tech, our mapping technologies, our marketplace, the core trip flow where the millisecond matters, and the Hadoop, the payments, infrastructure, and so forth. And we said, OK, so how much of this is, if we had to do a revolving door test and say, OK, let's holistically look at it, how much do we keep it here and how much do we take it in the cloud? And there was a technical answer, and then there was a non-technical answer, right? So when you look at technically what is viable, and hypothetically, if you were to start from scratch, you're a new organization, I think the technologies available in the cloud have reached a very mature state where you can push everything to the cloud. But the realities are there are organizations like us that are deeply rooted, as you mentioned, into our own data centers, and even to an extent that they are deeply entrenched to the physical hardware, let alone going to even the Mesos or AppDocker sort of a layer. So there's that whole technical aspect. It's like a whole use case, like what stage of your organization is in, what kind of technical challenges you have, but then also affordability. The big fear we still have, and all the organizations have, is the vendor lock-in and the affordability of cloud. It may look cheap now. In 2 years, will it continue to be cheap? And how do we make sure that we don't get stuck with one vendor? And until those problems are not resolved, organizations will always look at some form of a hybrid strategy that gives them that economical benefits.
Yeah, to your point on vendor lock-in, right? And one of the things I focus is that, right? So what we do is we tap into Slack server capacity that sits underutilized. I mean, 85% of capacity out there today sits underutilized in most of the servers, and our job is to bring them, aggregate, and provide an interface, and obviously only interface is serverless for us. And if you look at evolution of computing, right, in the beginning you had mainframes. It was a very centralized model, and you got to go to the mainframe to operate. Then the client server came along, and clients were equally as powerful as servers, so you had a way more distributed model. Then we went back to the cloud, where cloud became a centralized entity where you go to the cloud and mobile becomes the access point. Now we're seeing more decentralized and distributed architectures where to solve for interoperability is to solve for, that requires interoperability to be solved and scalability to be solved. So I think we're going to see as we move more into the decentralized distributed cloud, serverless will play a huge role.
And in this vision of the world, right, serverless wants to get rid of managing servers. That's the whole point. You deploy your function, and you forget about it. Your function will scale automatically. The cloud providers will deal with that. You will be charged only for what you're using, not for idle capacity that is there wasting resources. And in this world, how will the role of DevOps change?
There's a lot more complexity in the layers above. And I don't want to, again, undermine the complexity of managing the bare metal and the over-provisioning problems and so forth. But there are so many challenges in the layers above capacity management, outage mitigation tools, service dependency graphs. And to be very honest, the hybrid world creates a lot more complexity, distributed tracing, logging. I can go on. And we had a Sunday outage, so I'm a little bit burnt out. But the point is, the ideal scenario, combining your previous question as well, is ideal scenario is want to be in one cloud if I can just avoid that vendor lock-in. And even there, in that ideal scenario, there are tools that are lacking yet around the whole understanding of your application landscape that I think DevOps plays a huge role.
Right. So today, as it stands, it's unaffordable. That's my take. Give you an example. A 1 megabyte of smart contract on an Ethereum network costs about $13,000. On a EOS network, costs about $2,500. I mean, any programmer in their right mind wouldn't deploy a smart contract and expect it to run. And the problem happens to be today, most of the serverless, at least in the blockchain space, happen to be a monolithic and a homogeneous architecture. So it's a socialistic model, right? So you share the costs. Everybody shares the costs, and somebody has to pay. And by treating every application same, you don't necessarily provide the cost variance that you need to deploy a scalable workload. I think that needs to be solved. I mean, by decoupling. When you start decoupling, then the question becomes who's going to manage these different layers, right? So it's a very challenging situation we're in. But in time, I don't doubt it's going to be solved.
I think with the DevOps question, it can be either no DevOps if you've managed to reduce your service to only deploy to serverless. But the bottom line is that not every application can be deployed to serverless, namely durable services. So someone has to manage the database. Now, if you go all in on, I only use managed services, I think what you described, the surface will be looking at your metrics, looking at the graph of your services, looking at the connection between functions, and responding to events like elevated latency. That would be, I think, or changes in business metrics as a result of outages and incidents and so on. So the surface does get reduced a lot, but it does depend a lot on how much you bought into everyone else manages the infrastructure for me, which is a way of saying it's someone else's DevOps problem.
But it's also, it creates new jobs that we are just starting to see. I mean, full-time job just to understand the bills that you get from a cloud provider, I think is incredibly necessary. Those things are very complex and opaque. Full-time job of what used to be capacity planning is now known as keep your cloud vendor honest. Are you actually getting the capacity that you were promised is a very big question as well. So I think we see it on every kind of big technological shift. Some jobs are no longer as valuable. Some jobs are just created to handle the new challenges that are exposed. But you are right. Everyone that I know who is like really, really good at running databases now works for a large cloud provider. It just feels like some key technologies that is disappearing from the world.
Just like, when the last time you thought about changing a disk on a server, right? What we're seeing is when it comes to verification, when it comes to proving, there are amazing work happening in cryptography world where you can, if you have a function, functional abstraction is much more easier to formally verify whether the code ran or not. So you don't really care about, what you care about if the code ran in the amount you require it to run, right? So as we move into a more decentralized world, we're seeing cryptography playing a big role in verifying performance. So
yeah, look, there is going to be that last mile problem. Like we know last mile is always the hardest, and what I mean by that in this particular context is that customization that you need in your monitoring, alerting tools, tracing tools, and so forth. I just feel like 2 years back, the problems were not that complex, and now even your basic monitoring tool, the dynamic thresholding is also not enough. When we look at the abuse attacks we get, there is enough sophistication in the market where it remains below your dynamic threshold, not just static threshold, even below your dynamic threshold. And we literally have to now go into pattern matching of how these patterns evolve over a period of time. So when you go to that last edge of the edge, it's not going to be ever solved by serverless, and you will always need your smart DevOps within your company who understand your business along with your technology and create that customization.
And how you think, in conclusion, how you think that serverless technology will develop from here? Come on.
I'll start with
Guillermo?
reiterating what I said earlier, which is I think every single app developer will only interface with a serverless type abstraction. So the people that develop user-facing applications, business applications, the surface that serverless gives them is enough that they can be extremely productive. One of the things we do at our company is we enable a GitHub integration where every single push gets automatically deployed, and we give you a URL back for every single push. Just think about what that does to QA and product development. You can delineate the conversation and collaboration around source code with such frequent deployments that you're just discussing, the outcome of how good your application is. So I think, to Gwen's point, it's going to be hard to turn down this for any organization of any size. Now, I think we're very interested in how to bridge the gap as well to the existing infrastructure, because I think the existing infrastructure will have a lot of momentum and a lot of inertia, and we'll have to figure out ways of being very good at connecting to those, at providing a workflow to connect to those, providing the security characteristics that are needed, the latency characteristics that are needed, and ultimately upgrading people's businesses and minds to embrace this, to embrace the idea that the individual developer within the team can do more, can deploy more frequently, can run experiments in production, such as canary and A/B deployments. All those tools will become available to every single person within the organization.
So I absolutely agree with that bridging aspect, right? Like that seamless end-to-end monitoring is seamless end-to-end management is going to be very critical. I do have, though, an additional perspective here. Serverless companies will have to start thinking about their total addressable market. And that is going to be the 90% generalized use cases that you see in the world. And when you step back and look at that TAM, that part of the market, there is one big aspect I feel missing, which is what I call, and I just framed this term a few days back, which I'm trying to evangelize, is contextual paths, right? Like, so there are layers that these companies are solving. But then, if you look at startups and even mid-sized companies, there are some very known problems. They all need marketing analytics tool. They need payments integration. They need all of this other insight development and so forth. You can provide these as a service on your serverless cloud and take away. These are important. Of course, everybody needs to be paid. These are all ridiculously important services. But how much of these can be this quote-unquote overhead can be taken away from startups and let them, again, focus on their niche value prop is going to be huge.
This is very good. This is very good. We perhaps have time for one question from the audience.
This question is more so for Greg, because he mentioned something that I can relate to. Because whenever, I have experience deploying serverless with AWS Lambdas, but every time I take it to a head of the organization that makes big decisions on microservices and bring them like, hey, how much of our services can be moved to the cloud? There's always this conversation that comes out that comes back to, hey, the financial model involving how people manage these serverless endpoints are kind of complicated and not measurable right now. What do you guys think about it? Is that a conversation that's real? I just want to hear more about that.
It's real. It's very hard to estimate your serverless deployment. And it's a problem I don't think any one of us here have a solution to. We're all working on different models, but it's extremely complicated.
It's very real. We have been spending months on that pricing model forever and ever, and whenever we come up with one, there is always a negative opinion about it.
Right.
So.
Good. Thank you very much.